so it says explain why log base 0 of 3 and log base 1 of 3 do not exist. So anybody have any ideas? So let's set each one equal to x. Think about them in exponential form. What would the first one be?
It's always going to be 0.
Yeah, it's 0 to the x equals 3. That would always be 0, right? So 0 isn't equal to 3. So that can't work. Okay, how about this one? This is 1 to the x equals 3. Yep, so 1 can't be equal to 3. So this doesn't work either. So that's why in our definition we said that your base can't be 0 and it can't be 1. Okay, it actually has to be always greater than, well, it has to be greater than 0. It can't be negative either. All right, so number 2, use the given x values to graph each function, then graph its inverse. This is kind of what we just did. So if I have 3 to the negative 2, 3 to the negative 2 is 1 over 3 squared, so 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. And 3 to the 1 is 3. Oh, and 3 squared is 9. Okay, so we're going to graph those points. This is going to be our exponential function. So I have negative 2, 1/9. I have negative 1, 1/3, so a little bit bigger. I have 0, 1, 1, 3, 2, 9. So this one's the original. Okay, so let's graph its inverse. So for the inverse, all of the x values from before are now going to be all the y values. And all the y values from before are now going to be all the x values. Okay, so I have 1/9, negative 2, 1/3, negative 1, 1, 0, 3, 1, 9, 2, so that's way out there. So see how it's just reflected across the line y equals x. So that's why that's working like that. Okay, you got it? Okay. Is the what? The bottom of the log going to be what?
The log, the bottom one. The log.
Yeah, the bottom one's the log, yeah. So this was log. So what would it be? Y equals log base 3 of x, right? 3 to the y equals x, but your x's and y's switched. So that's why. Okay, so in the last class they were like, why do we use logarithms? This is dumb, I hate this. So use logarithms all the time. So have you guys heard of like carbon-14 dating? Yeah, so carbon-14 dating, that uses logarithms. pH scale, logarithms. There's all kinds of scientific applications for using logarithms. All right, so the pH scale. So it says the concentration of hydrogen ions. We denote it as H raised to the plus sign with brackets around it, so H plus, is given in moles per liter, reminding you of chemistry right now. It measures the acidity of a substance. Have you guys ever tested the pH of anything?
Yes.
Yeah, we're going to do that in here too. So it says the neutral substance water is given a pH of 7. Things with pH less than 7 are acidic, so like limes, lemons. Things with pH greater than 7 are basic, so that's like milk. That's base. All right, the acidity of a substance can be found by the equation pH equals negative log of H plus.
Oh my god, I remember this.
All right, so we were given, so number 1, it says the hydrogen ion concentration in moles per liter of a certain solvent is 0.00794. So that's your H plus. Okay, write a log equation for the pH of the solvent and find the pH of the solvent. Okay, it's really easy. You just do negative log of that number. Okay, since it's just log, there was no little number. It's log base 10. So log base 10 you can do on your calculator. So on your calculator, do negative, hit the log button, 0.00794. So I got like 2.10018, somewhere around there. We usually round to 2 decimal places. So 2.1 is your pH. Okay, so let's try the next 3 examples. So it says the hydrogen ion concentration of 3 juice samples are given. Identify the type of juice in each sample. So these are the hydrogen ion concentrations, so that's what we plug in to our equation. So let's find all 3 things. So round to 2 decimal places. Okay, what did you guys get for the first one? No one did it? 0.9? I think it's bigger than that. Oh, 3.9. Did you say 3.9? Yeah, I just heard 0.9. All right, 3.9. All right, second one? 2.1. Did you guys get that? Third one? 3.1. All right, so what kinds of juices are these? So A is orange, yep. B, lemon. C? Did you say? Oh, grapefruit. I think I said grape. It's like, I don't think that's a choice. Okay. So orange, lemon, and grapefruit. So those are pretty easy. Those should be easy test point questions, right? All right, so what you guys do is you see something like this, and you freak out because it's a big, long story problem. It's not hard. Read through. You can do it. Okay, it says the flower color of a big leaf hydrangea is determined by the soil pH. A gardener is growing blue hydrangeas, and she believes lime could be leaching out of a nearby sidewalk, causing the pH to increase. Okay, so it's more basic. It says the gardener measures the hydrogen ion concentration and finds it to be 0.0000006 moles per liter. All right, so 6 zeros there. All right, then it says if the pH is between 5 and 5.5, she's going to get a blue hydrangea. But if it's between 5.5 and 6, she gets a purple one. And if it's between 6 and 6.5, she gets a pink hydrangea. So is she going to get the blue hydrangea she's trying to grow? So it's real easy. You know the hydrogen ion concentration. So when you do that, what do you get?
Pink.
Pink. What was your number, though?
Oh, 6.2.
So 6.2 something? All right, so 6.2, so that's between 6 and 6.5. So she's getting a pink hydrangea. So she's got to do something to alter that pH of the soil. All right, so that's the end of that section.